Okay, so hi, I'm Tobiasz. As Somek mentioned here already, I work here at Ingrid, and today I would like to talk about best practices for handling Black Week traffic, or Black Friday or Black Week. And let's begin. So first, we will talk a little bit about Black Week and how the traffic behaves and what is Black Week at all in e-commerce and software, how to prepare a suite for load tests, and how you can find the bottlenecks in your system. And if you are good with time, I prepare some basic demo to show scaling and some debugging in Go, like in a real simple way. So let's start with what is Black Week at all. So basically, it starts, at least this year, it started the weekend before Black Friday. So we saw that the traffic is increasing to our solution, and it's more or less 10 days. It's keep up to Cyber Monday, and it's like basically much bigger traffic than in normal days. I will show you the numbers in a few seconds. And why is important? So few of our merchants prepare for this period, since marketing they have some plans and they prepare strategies to put some good records or good numbers of sales there. And what's also important, so there are a lot of new marketing strategies right now, and for example, this is what was impacting us. So right now there are influencers, and if they share some advertisement on the social media, you will see the peak in the traffic in a few moments. So it's also your infrastructure needs to be prepared for it. So right now I will talk a little bit about our architecture, but I think I forgot one slide, that what we are doing at all, because maybe it's important in the e-commerce topic. So we are building the it's like in the easiest way is like a PayPal but for shipments. So on the checkout side, on the merchant side, when you go to the checkout, you often need to select proper shipments, and we deliver it as a software as a service, and merchants can integrate with us. And yeah, so we are mostly in all e-commerce. I don't know, but we only work with e-commerce, and this Black Week period is very important for us. Yes, so these are more or less the number to our core service. So in a single day in January 2020, we have 50 requests per second. And this was more or less our requirement for Black Friday, so that we need to handle 3,000 requests per second. So you can see that the difference is quite big, and after all, this is the number that we finally hit during the live. So it was 200 requests per second. So actually we're prepared for much more. And let's give you a short overview of our architecture. So more or less we have 18 microservices. Almost all are written in Go. We are using Kubernetes on the infrastructure, and we are hosted on GCP, only on GCP. And basically we use gRPC and Google Cloud PubSub for our internal communication, and we expose REST API via gRPC gateway to our clients. So right now we can talk a little bit about different traffic types. So I think we can divide it into two categories. So first one is high and stable traffic. So it's increasing slowly, like over a longer period of time, and it's actually easier to handle because your infrastructure have time to adapt to this traffic. So you don't need to react immediately. So it's easier to handle. And this other is this traffic spike. So different different sources can cause this traffic spike, like this influencer advertisement, or some like merchants send the newsletter about some discounts, and it results that you have immediate peak in your traffic, and this is different kind of traffic because you need to handle quite big. The traffic is increasing in very short period of time, and your infrastructure needs to also handle it. And yes, so right now we'll talk how you can simulate high traffic, because we already, like this year, we started preparing for it 1 month before Black Friday, and to be honest, it was like not enough time. That we spent a lot of time improving our infrastructure, and we finally were able to handle this 3,000 requests per second, but yeah, it was like quite crazy time. And so you need to begin with preparing test schemes. So what I mean by that, you need to understand based on some metrics what kind of requests and how often different kind of requests are going to your system, because probably you have like multiple gets and updates, and you need to simulate the live behavior in your test. Then what we did is bootstrap this test in some staging environment, just to be sure that you don't break anything. So we start with staging. We already found some few issues there, and when we have on stage, we have only one instance of database, and when we are already hitting the limits of it, we move to the production. So at the beginning, it was, you were always not feeling quite safe when you're running this load test in the production. But if you have good observability, which was of course struggling with it, but if you have good observability, then you are sure that you're not breaking like your production rate during the test. So let's take a look on the observability. So for metrics, we are using Prometheus and Thanos. Thanos is like addition to the Prometheus. It provides you high availability and infinite retention of the metrics. And what's also important that your metric system needs to scale with load. And for us, it was a big problem because we already before we were producing like very big amount of metrics, and we were during this load test, our metric system was not able to handle the load. So even if we were putting some load into our system, but we weren't sure if our production is still running or not, or we see some service degradation. So we're struggling with it quite a bit, and finally we need to introduce some sharding of metrics on the Prometheus level. And with this solution, we still have a huge amount of metrics, but they are sharded between different servers, and this was a good solution, at least for us. And what's more, with this observability, you also need to have some kind of alerting that you need to stop the load test immediately if you see that something is breaking. And for us, it was also like before, our alerting system was not the best one, so we was spamming a lot, and a lot of us were ignoring it. And basically what we did, we spent some time and separated this like really important alerts. We call them on-call alerts, and we put it into one Slack channel, and we know that if those alerts are triggered, that you need to react somehow, and other alerts are not that important, they are on the separate channel. And I've also added this point, that the alerts need to be easily configurable and adjustable. And this is also what we are struggling with. If it's not easy to change alerts, probably it will be very hard to maintain it. So we need to be able to adjust the values, the thresholds. And if it's really easy to do, then it's high probability that other developers, like including also me, will care about it. So this is also very important. And so what we actually use for simulating high traffic is this Locus.io. It's open source load testing tool. You define behavior in Python code, and it's distributed and scalable. So what we used is Helm chart with locus cluster. So you define how many workers are there, and you have one master which is used for configuration. Then these workers are simulating high loads, and you also have web-based UI. It's looking more or less like this. So on the I forgot to put configuration here, but you define how many users you have and what is the hash rate. And hash rate is how many users are spawned per second. So basically, with these parameters, you can define this traffic spike. So if you put it quite low, you will have this slowly increasing traffic, and if you put it higher, you will see these traffic spikes. And yeah, and we are quite happy with this locus. We didn't have any issues, so it was very, very good for us, and I can recommend it. So Wazzle, then let's take a look how Kubernetes behaves. So basically, what we're using for scaling is horizontal pod auto-scaling, and it can be configured to scale both based on the CPU usage and the memory usage. Actually, when you write services in Go, they are, at least in our case, they are more CPU consuming. So basically, we ignore this memory and we just scale based on the CPU. So first one is this pod scaling. Then you have node auto scaling or host. That if you need to have this node auto scaling, because when you are triggering new pods into your system, you need to have this solution with some node pods that scales with your load, and at least scaling on GCP from 10 to 100 nodes works in a few minutes on GCP, and we didn't see any issues. And what else we introduce is, we called it resource placeholder. So basically, like last year we had some issues with this node auto-scaling, and we are not trusting it so much. So in Kubernetes there is this concept of pod priority. So if there is no enough space on the host, or we call it node in the Kubernetes, and if it tries to assign new pod, and if there's already pod with the lower priority, it will be deleted from it, and a new pod can go into this node. So we create like few placeholders on different nodes that they, in case of it, there was just empty container with sleep and response to the health check, and when there was like high load and there was not enough space on the node, it will remove this this placeholder and put the actual pods. And actually, we tested it and it was working, and we didn't see it in the live scenario, but we saw it a few times during the load test. So this is another topic with Kubernetes. So right now we'll see how we can define resources, and this is, at least for us, it was not easy topic, and we are struggling with it for some time. So in Kubernetes you have two kinds of resources. So first one is the requested one. So Kubernetes will schedule your pod on a node that can guarantee you the requested resources. What we find out is that for Go application, you need to assign at least 100 millicores of CPU, at least on GCP. If we put the number lower, it can result in like weird behavior, like very slow response time, and we just take this value as a base to all our services, and some is more. So then every service was adjusted manually if it's needed, but this is the base low level. And there's second type of resources, so this is limit, and if the actual resources used by this pod is above this limit, Kubernetes will kill this pod in order to prevent like memory leak, for example. And you need to set those values also, and you need to set it properly, because if you put this value too high, it can result in a situation when actually you will starve your node. So it will be using much more CPU than requested, and it will still not reach the limit, and Kubernetes will not, like, this node won't have the CPU or like free CPU for other pods to run, and you will see very weird behavior. So basically this is our number that we just put additional 20 to 30 percent points from based on the request resources. And this is also important because you need to put this number bigger, because if you start putting the load before the autoscaler will trigger the new pods, this pod needs to handle this load before, like, it cannot be killed because it's using more CPU. So based on our experience, I would recommend for Go application this kind of numbers. And I will show you this HPA in a second on the live demo when we will go also to profiling the Go application. And right now I would like to talk about our database setup, because we already before test we were quite sure that this will be our bottleneck. So we are using mostly MySQL, and before preparing for the Black Week, we have like more or less 4 MySQL instances on the production, and we have 1 Postgres, and we also were using Redis for caching. And actually, we like all of them are managed by Google, but we have a lot of problems with Redis. Like we're starting in a weird situation, and the fallback was not working fine. So we decided that in every service it should be optional, and so each service can run without Redis, and then we move to the in-memory cache. But right now, let's take a look on this database bottleneck. So first one is CPU limits. So as I already mentioned, we're afraid we will start hitting the CPU limit. So what we did, so we moved each of our core services per separate database instance. You also need to somehow monitor your queries, because then you can find like very CPU consuming, and maybe you can improve them somehow. So we are using more or less we forked this library, but basically it can give you the instrumentation to your SQL queries in Go in quite easy way. And yeah, based on it, you can, if you have some numbers based on the metrics, you can review if your queries, and maybe you have some unnecessary indexes. This was the case in our core service, because we still didn't trust because basically right now you should have 2 separate data sources for services. One is for the real transaction, and second one for analytics. And we still didn't migrate our old analytics indexes, and this was the time that we actually decided to delete these analytic indexes from our database. And lastly, you can also apply vertical scaling to your databases, and we have this single instance of MySQL to our core service, and after all, we use 32 cores of MySQL CPU for the Black Friday. And another bottleneck is a number of connection to the database. So in Postgres, at least I think in the version 9.6 is around 100 or 200. In MySQL, it's around 5,000. but it's still, you can reach this limit quite easily if you scale your pods like crazy. So for example, if each pod have 30 CPU, 30 connections to the database, and you have 100 pods, you already have 3,000 of connections, so you are almost half of the limit. But it's important to cache connections to the database, because based on our finding, like creating time to create new connection, it can take up to a few seconds, at least on GCP. So we decided we are caching at least 30 connections to the database in each microservice. And then if you want to don't want to hit this limit, so also the separation of instance per service helps. And you also can create bigger pods, because if you have bigger nodes, like if you duplicate the resources, you have 2 times bigger pods. So basically it should, like, instead of 2 pods, you will have 1 which can handle the same load. And there was one more limit that we actually learned on the production, that there is GCP has its own database limit. So this is like the default. So how many new connections to all database in your GCP project can be created per 100 seconds. And we didn't know about it, and during one of our load tests, actually we hit this limit, and I think our production for a few seconds were like not able to create new connections. So it's also important that sometimes your provider can limit you somehow. But finally we were able to say it. I don't remember if you need to contact support or not, but we are able to change it. And also here the bigger pods helps with the less amount of active or new connections. So as I already mentioned, we're not like very happy with Redis, and we invested in memory caching Go, and like we started with one of our core services, and it has some, like before it was using our own solution, but it was maybe not the best one, but it has 2 concepts. So you have some entries that you cache in memory, and you put validate field and fresh field. And basically what it does, so if the entry is no longer valid, then if you try to ask for this entry, it will get it from the source synchronously and give you the result. And the fresh entry gives you the information if you ask for this key and it's not fresh, but it's still valid, so it will return not the fresh value, but it will ask in the background for the fresh value. And we decided to move it around, like to create out of it the library, which like one of the most focuses optimized for fast reads, and it has like built-in mechanisms for this sync and async refresh of entries. So basically you just define the producer, so how to obtain the value, you define it on the initialization, and then you, like normally if you use some cache, you need to get entry, then if it's not in the cache, you need to fetch this entry manually. And with this library, you define this producer up front, and then you just get. And if the entry is not in the cache, it will download it automatically. And if it's fresh, if it's not fresh but it's valid, it will return it immediately. But in the background, it will get the fresh value. And we are really happy with this solution, and we introduced it in few of our services, and we also have plans to open source it and probably do some other talk on the meetup about this. So it's, yeah, we are quite happy with it, and it's also done this way that you can actually use your own backend as a cache. So there are different solutions of the cache in memory caching Go, and you probably can replace our solution with someone else. And this is just like the interface for getting the values from cache. Yeah, so right now I would like to talk how to find the bottlenecks in your Go application. So profiling helps a lot, and pprof is so with pprof you can get the profile out, like CPU profile for example, and also memory out of your application, and it has very small impact on the runtime. So actually you can enable it all time on the production, and you just request for the profile from a given time, and you can actually analyze the live data in a few seconds. And like, I'm not an expert in it, but when you're viewing the pprof profiles, you can use flame graphs, and at least for me they are very easy to read, and I will show it in a few seconds. Okay, so maybe let's continue. So one of our findings is that we actually, in our logging library, we replaced the standard library JSON with JSON iter, because it was one of our most CPU consuming operation. And also with the pprof we're able to find out that building the traces, because one of our colleagues before Black Friday were trying to introduce distribute tracing, and actually building the SQL traces was taking like most of the CPU in one of our services. So we are also able to discover it and remove it. And also, yeah, on this profile you can find out that creating new connections to the database take a lot of time. So I've prepared a small demo right now to show you the profiling and auto-scaling. So here is a very simple application. I will also put the link to the GitHub after presentation, so you can view the code. But basically, what it does, it's simple web service which has two endpoints. One is for telemetry, and second one is that simulates some API. And this telemetry, what this does, it serves the health checks and readiness checks to the Kubernetes, and it also provides this pprof profiles on one of the endpoints here. And basically this health check is all-time respond with status up and status okay. And yeah, and this serve, what it does is, in the default row, it's just simulating some work. And what I'm doing here, I'm just creating a new map with some, and I'm using some UID as the key and values, and I'm just later marshalling it, and it's created like 100 times in order to simulate some work. So that's the Go application code. Nothing fancy here, and yeah, and here are the Kubernetes configuration. So first I'm declaring the service as a load balancer, so actually then I will be able to expose this service externally to the world, and I will be able to put some load on it. Then there's definition of deployment. It's also nothing fancy here. I have these two ports and some definition of the readiness probe, and then here we have this horizontal pod autoscaler, and what you define here is minimum and maximum number of replicas, and we are taking CPU into consideration, and if it's above 30% above the average from the old pods, it will create new. Yeah.
I have a question really regarding the other way of scaling. You mentioned scaling of the node.
Mm-hmm.
So I don't know how it is in Google Cloud, but in AWS, the EC2 instance can have a predefined number of IP addresses, which is limited. I'm not sure if it's 40 or something like this, but that means you can have only this number of pods, different pods with different IP addresses within one EC2.
Mhm.
You said that you were scaling nodes as well.
Yes.
So how this works in Google Cloud? Could you elaborate on it?
So, because I'm not AWS expert, but you're saying that you have limited number of pods on the
addresses.
but on the one node, right?
Yes.
Okay, so I'm
No. Internal. So when you create a service, it serves you a new IP address, right? So on one machine, this number is limited.
You have a network there, and there is how big the network is.
Mhm.
So you will automatically allocate the addresses by your whole network stack, depending if you have 1,000 IPs or 100 IPs.
Oh,
Depending on the mask you set up in Kubernetes.
All right. So it's not
So you
limited.
see /20
Yeah.
there?
Yeah.
You see?
So it's limited by the mask.
Yes.
Yeah, and basically I saw somewhere the node the parameter how many pods can be on the one node. I think it's like 115, but I saw that it's editable. But so probably you can edit it. But
Pod
yeah.
address range there.
Mhm.
That's your address space.
Here is this default maximum pod per node. It's 110. So, and I think when you create new node pool, you can edit this value somehow. But like we are not hitting this limit, so I cannot like give you more information here.
Yeah, so in AWS, otherwise you would have to terminate your instance and spin up a new instance with a higher number of cores and memory and run a new node on it. So and then spin up all the pods again.
And then it becomes too complex to use AWS. Just
But I am in the previous step.
Yeah, so basically we didn't have any issues here, and you also can define different node pools here on GCP. So you can have like the pool with like 4 CPU, and then you have other pool with 8 CPU. So it's also working quite good. Okay, so this is this definition of HBA, and if I just deployed it, so here we can see the two new nodes are created. Two new nodes are created. Two pods are created, and I've also here this have this. HBA, so we need to wait a few moments in order to measure the CPU, and then we can start. And I will just show you. So I've deployed this service before because it takes some time to get this external IP. And yeah, so let's wait a few moments, and we'll see how it works in life. Anyone has other questions while we are waiting? Yeah.
So I have a question. You said that the performance really wasn't the case for you because when the CPU, for example, was exhausted, you just spawned another instances. And from the other hand, you're using the kproc. My question is it really that you never had to do some low-level optimization, like for example avoiding the pushing the memory to the heap?
No, for us it was easier to spawn new instance than to like focus on this low-level optimization. So it's if you just put we are using Profile to find some obvious cases. So for example, if something is obvious like this JSON encoding, then you can replace it in a few seconds. Then we will do it. But last year we have very bad experience with Black Friday. We did some few commits, few changes that actually were very badly for us. So this year we tried to not do huge changes. So we focus if you can find something obvious, then you fix it. But if not, then you just auto-scaling was working quite well. So you just let the auto-scale spawn new pod and it will handle the more load. So we know that our services are not optimal, but with this auto-scaling they were able to handle the load and scale without any issues. And actually the only bottleneck were database, not the scaling of services itself. Yeah?
When I use auto-scaling and I load test, it scales up, everything is fine. The problem is then you stop the load and it never scales down back. It makes I don't know, 50 nodes, and then it stays at 50 nodes for 2 hours before it goes back to 10. You ever had such an issue?
We not
it
that
doesn't
big.
downscale very fast.
No, this HBA at Kubernetes have these different values when it checks if it needs to scale down or up. So maybe I'm not sure if you can adjust it on the GCP.
HBA is for the pods.
Yes.
The auto-scaling of the nodes is from the config panel on the side.
Yes, but I don't remember the correct number, but if the load is on the node is lower than 50 or 40%, it will try to kill this node after, at least for us, it was after, I don't know, few minutes or up to 1 hour, and it will delete. So we are able to scale from 10 to 100, and then we are able to go back to the 12 without.
Never experienced issues.
No. We experienced it after load test. There were distribution that instead of 8 nodes, we have 12 or 13 with the 50%, not on the 70%, but not that it didn't scale at all or after a few days. So we didn't experience it.
And I found myself in a position where I have to go and delete the nodes myself.
Yeah, so
underutilized. They don't go down.
When it was this year or before, because I remember that 1 year ago we had some issues with the auto-scaling on the node auto-scaling on GCP, but this year I think it's better. So
Currently I'm just getting the nodes manually and then adding the HPA.
Yeah, so right now we have some information. So we have 2% of this average CPU usage, and I have here. Okay, so this is this endpoint, which is doing some work, and we can actually check. It should. So actually, you can see that this pod was doing something, and right now I have prepared. Hey is very simple command line tool for simulating load. You just define the first parameter is how long the test will take. Then you define number of concurrent requests, and Q is request per second, I guess. Yeah, and if you run it, you will see that after a few seconds, we will see here the CPU measurement go up, and it will scale the new pod. And actually, that time we can. Okay, I'm just port forwarding. Yeah, and I want to show you how to profile it. So I will just port forward one of the pods, which is probably that right now. Okay, I need to do it once again because the test is finished. Okay, so right now you can see that it actually sees right now after a few seconds the load is higher, and if a few seconds it will scale the new replicas. And that's what I told you about this traffic spike, that your your pods needs to tolerate some higher traffic before the HPA will react, because it react based like after, like it has different threshold, but I guess they are more or less around 1 minute. Yeah, so right now it's went first from 4 replicas and then to the 8, and you can enable it once again. And right now I will do port forward, and I will download 5 seconds of this profile. And right now we can using so here I'm just downloading the profile from one of the pods, which are port forwarded here, and here I can view this profile. And actually this is not the best view, I'm just using the flame graphs here, and okay. And you can see here that most time that it's quite easy to read. I don't have like many functions here, but it's quite easy to read that, for example, most of the time it's using this UID generation. And here you can see how much time it's using this Marshall encoding. And just to demonstrate you like what we can do in a simple way, just replace this JSON. This is standard library JSON. And very easy, you can JSON it and you can just replace it like this. We'll just build a new image and it won't work. I'm still using the vendor. It's also pushing the image to the Docker Hub, then I can easily download it from the Kubernetes deployment. We don't have the fastest internet here in the basement. Okay. So then I need to change the image ID here, and I'll just and it should it will trigger the new deployment of the new pods, and if in a few seconds we'll do once again the profile just to show that it should be better right now, at least the JSON CPU usage, JSON encoding. Okay, so actually we can start right now if we have some port from this one is already used, new one. So put some load, and here we have this port forward. Bless you. And if you use profile, So you can see right now that this JSON encoding is, I guess, yeah. You cannot see it anymore at all. Here is just JSON interactor Marshall, so it's using much less CPU right now. And that's all from demo. Yes. And yeah, so some other stuff that we find out during this Black Week period. So actually pair programming helped us a lot. We weren't using it too much before, but during this time we started using it, and yeah, you decrease the probability of errors when somebody is watching your hands, or if you switch from something like regularly, and yeah, and you also produce the better quality code, and it's also a lot of fun, at least for us. Like if one of your colleagues is using Golang, so you can make fun when he's like when Golang is indexing files, and when you are using VS Code, it's probably making fun of you when you are restarting Go please all the time. And some others, so you use like we were able to reduce some of components on our critical path just to be sure that it won't break. So we're able, like one of our core components is configuration of each merchant, and right now our services can live without it. So it is cached in each service, and even if this core service go down, our services can still works with maybe stale configuration, but it will work for some time. So we are able to reduce few components of from our critical path. We also were able to change some synchronous communication to asynchronous where it was possible. It also helped us a lot. Yeah, and basically these are our images from this week, Black Week. So we are actually prepared for higher load, and we're we're feeling quite safe. So we actually during Black Friday we are able to play on the PlayStation. So yeah, I think it's cool. And what we have future plans, so probably we need to invest some time for distributed database. And that's all. Thank you.